Good day, everyone. Today, I'm going to discuss the hexagon in nature. Aristotle once said, nature abhors a vacuum. Well, if nature abhors a vacuum, then surely nature adores a hexagon. Hexagon arrives in many different areas of nature. If you have ever wandered around in nature, you may have noticed how many geometric shapes there are in the world that have absolutely no designs from humans. Hexagons, in particular, are often seen in nature. For example, beehives, that is one of the common example of hexagon, but definitely not the only one. Dahil marami pang mga halimbawa ng hexagon patterns. Isa dito ay ang basal columns and insect. But have you ever wondered what makes the hexagon so special? Guys, the hexagon is the strongest shape known. But many people didn't know this. But if you want something to hold a lot of weight, pick a hexagon. Hexagon patterns are prevalent in nature due to their efficiency. That's why hexagon is a very special pattern. Why does this one shape arrive in so many different places? For example, bees required somewhere to store their honey, so they build storage cells which made up of hexagonal pattern. Hexagon is the closest shape to the ideal circle, so this is the shape they use to build a honeycomb. So, why does the bees use the hexagonal pattern to create their house? So, bees use the hexagonal pattern because no shape is better to create the maximum area for the minimum wall. Each hexagon is a long tube that leads to the catching cells at the bottom. So, more light is equal for our better vision. Then, hexagon let the most light in using the least amount of wall. So, ang hexagon pattern ay mas mabuting gagamitin dahil mas nakakapasok ang mas malinaw na ilaw. So, magre-result yan sa mas malinaw din natin na pananaw sa mga bagay-bagay. So, alam nyo ba na ang ating mga mata ay gawa din ng meron ding hexagonal pattern din ito. Ngunit sa labas is circle. Pero sa loob ng ating mga mata ay ito ay hexagonal pattern. Dahil, 'di ba? Sabi ko kanina na ang hexagonal pattern is the closest shape in circle. So, yun ang dahilan kung bakit yung mga mata natin ay sa labas ay circle, pero sa loob nito ay hexagonal pattern. So, in order for you guys to understand more about my discussion, I am going to give examples and explanation about hexagon in nature. I'm going to present in the next slide. Sections on a soccer ball. A soccer ball or a football is made up of a number of the pentagon and hexagon shaped sections aligned one next to the other. Hence, one of the prime examples of the hexagon geometric figure can be observed by looking at the lighter sections of a soccer ball. Snowflakes. All snowflakes contain 6 sides or points owing to the way in which they form. The molecules in ice crystals join to one another in a hexagonal structure, an arrangement which allows water molecules, each with 1 oxygen and 2 hydrogen atoms, to form together in the most efficient way. Honeycomb. One of the most common and naturally occurring examples of a hexagon is a honeycomb. The 6 sides, 6 vertices, and 6 angles of each cell of a honeycomb make it a perfect example of a hexagon. Hexagons appear in honeycombs because they're the most efficient way to fill a space with the least amount of material. The surface of a tortoise shell is covered in bony geometric shape called scutes that are packed tightly together. The scutes in the center of the shell are hexagons. And now let us move on to Team B video presentation about the golden ratio.
Good day, everyone. I'm Alexandra F. Cortado from Section Delta, and for today's video, I am going to answer the 3 related questions about the video I've watched. So the first question is, what math concept is fully discussed on your assigned video? The math concept that is fully discussed on my assigned video is all about the golden ratio and Fibonacci sequence in music. Number 2, what is all about the concept? Cite few more real-world cases or examples that would show the concept. So the concept is all about the use, the importance, or impacts of golden ratio and Fibonacci sequence, especially in music and in nature as well. There are some people say that the golden ratio and Fibonacci sequence are evident in music. Yes, it is. Like for example, the xylophone. Why xylophone? Because xylophone has a rhythmic pattern following the golden ratio and Fibonacci sequence from low to high, and it's very beautiful to hear, isn't it? Another example that show up in nature is that flowers. If you look closely to the flower and you start counting its petal, most of the time you'll find a Fibonacci sequence. Another example is the sunflower. As you get closer to its seeds, it turns the optimal angle of where they are arranging themselves is related to golden ratio. The last question, what are your insights about this mathematical truth or certainties? My insight about this mathematical truth or certainties is that math is not all about a series of numbers. There are many things in this world, in our nature indeed, that is related to mathematics. Even in music, there is also a math concept. So all we need to do is just look at them closely and appreciate them all. Thank you for watching!
Good day everyone, this is Dayan G. Dumilid, and this video was talking about golden ratio and Fibonacci in music. And I will discuss what my topic about, so let's get started. So, question number 1, what math concept is fully discussed on your assigned video? So, golden rectangle, the ratio between its sides match pi. So, cut a square of a golden rectangle and create a smaller rectangle with the same proportion. So, because this long irrational number made sense visually but could be explained as a fraction. Let's proceed to question number 2. What about the concept? Cite few more real words cases or example that will show the concept. So, based on the first question was talking about rectangle. So, rectangle whose sides are proportional according to the golden ratio, which is 1.618. In other words, the long size is 1.618 times the size of the short sides. Golden ratio, that is A plus B equals AB, where is the width and the A plus B is the length of the rectangle. So for the last question, what are your insight about this mathematical truth or certain test? So for me, golden ratio has two numbers and are in the golden ratio of the sum of numbers. So A and B divided by the larger number. So A is equal to the ratio of the larger number divide the smaller A and B. So for example, rose, lilies, buttercups, and also rose are all Fibonacci flowers. So the spiral of the fine cone equal to Fibonacci number. So the petals of the flowers are arranged in Fibonacci sequence. The seeds of sunflowers follow a Fibonacci patterns. So the Fibonacci sequence goes like this: 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, and 89, also and 144. So the next number is found by adding up two numbers. Before A, 8, 0 plus 1, 1 plus 1 equals 2. So 2 plus 1 equals 3. 3 plus 2 equals 5. 5 plus 3 equals 8. So 8 plus 8 equals 13. 13 plus 8 equals 21. And so on.
I am Gabriel Fortit, a first B is Criminology. Right now we were talking about golden ratio and Fibonacci sequence. First, what is golden ratio? So golden ratio was named by the Greek in the world of mathematics. The numeric value is called pi, named from the Greek sculpture Phidias. In addition, this mathematical ratio can be found almost anywhere, like nature, sculpture, painting, and music. When specifically, it creates an organic balance and aesthetically pleasing composition. Fibonacci sequence is one of the most famous formula in mathematics. Each number in the sequence is the sum of two numbers from that precede it. So the sequence 0, 1, 2, and so on. This video talk about the estimation and quantity as one of mathematical concept. This concept is about a measurement of certain things where golden ratio was used. Examples are golden ratio in nature from measurement from the navel to the floor and the top of the head to the navel. Animals' bodies exhibit similar tendency. Include dolphin, the eye, fins, until all the golden section starfish, sandalwood ants, and honeybees. Golden ratio in architecture, the Great Pyramid of Giza built around 2560 BC. Golden ratio in art, the painting of Mona Lisa. My insight about this mathematical concept in terms of composition of any image, golden ratio can help to create a composition that will draw the eye to the important elements of the photo. Way back before, this method was being used and have a great contribution of the work of what we had now. I think their work before was much easy when they used this kind of mathematical concept.
Good day, I am Dennis Loares. In this topic, I will discuss of what I have understand about the golden ratio and Fibonacci sequence. Question number 1. What math concept is fully discussed on your assigned video? The concept of this video is all about the golden ratio and Fibonacci sequence. A golden ratio is an irrational number of p. Like p, it doesn't end. And Fibonacci sequence is a series of numbers where each number is the sum of two previous numbers. Question number 2. What is about this concept? Cite few more real cases or example that would. In a golden ratio, an example of golden ratio is golden rectangle. It's golden because both sides of ratio match P, and you create a small rectangle in the same proportion. In Fibonacci sequence in music, to create a melody, you use the number 1 and continue to sum the sequence and you create a melody. Question number 3. What are your insight about this mathematical truth or sentence? My insight about the mathematical truth or sentence: mathematics is essential for us to understand and solve certain things that are necessary in our daily life.
Hi guys, good day. I'm Ilson P. Kilan. So I have a 3 guide questions based on the video presented. First, what math concepts is full discussed in your assigned video? It discussed the golden ratio and Fibonacci sequence. So the second, what is about this concept? Cite few more real words cases or examples that would show the concept. So the golden ratio is found by dividing a lane in 2 parts so that the long part divided by the short part is equal to the whole divided by the long part. So it looks like the Fibonacci sequence to find the next term. So unsa ano to pangita sa next term? Ato lang i-add ang first term and the second term. So makuha na nato ang the next term, ang iyang third terms. So the third one is, what are your insight about these mathematical thoughts or synthesis? For me, the idea of golden ratio is universally found anywhere, and the Fibonacci sequence can be found in the nature. So pwede na to siya makita or makita na to siya sa bisan asa ang golden ratio. Ang idea sa mathematics, so ang idea sa mga mathematicians ilang relate sa nature. So nindot kaayo tan-awon na ang kining atong makita sa mga shapes or else unsa. So nakarelate po dai ni siya sa mathematics. Ang mathematics dili lang gid siya problem solving. So nakabase pud siya sa atoang nature.
My name is Perlito G. Lagisma, BS in Criminology, first year section Delta. Today, I will going to answer the question that are given after watching the video called Golden Ratio. Question number 1. What math concept is fully discussed on your assigned video? My answer is, it's about Golden Ratio and Fibonacci sequence. Question number 2. What is about this concept? Cite few more real-world cases or example that would show the concept. My answer is, for me, this concept is about the importance of golden ratio and Fibonacci sequence in our life and how it is connected to us. And some of example is our finger. Looking at the length of our finger, each section from the tip of the base to the wrist larger than preceding one by roughly the ratio of I. Another example is the pineapple and cauliflower. It has similar spiraling pattern can be found on pineapple and cauliflower. And the last question, what are your insight about this mathematical truth or certainties? My answer is, mathematics has a big part in our life, especially in the nature. We can deny the fact that mathematics in everywhere because wherever we go and whatever we do, we always use mathematics as a part of our life like business. That's why we need to have more idea our learning about it it and gives important of its use.
I am Kevin Garcia Libasada from Section Delta. Today I will discuss. There are three assigned questions for our group. The first question is what math concept is fully discussed on our video assigned. So the golden ratio. Number two is what is about the concept. Cite few more real world cases or examples that would show the concept. The golden ratio was, let's start in our ears. Our ears has a form of the golden ratio. In nature, we can see also the golden ratio like the pineapple skin. Its eyes-like skin has the golden ratio form on it. And number three, what are your insights about these mathematical truths or certains? My insights is that mathematics or the creation of numbers was created based on our surroundings in our nature by the word itself golden, so we cannot deny that gold is very expensive matter, but let us look at another way. Gold is very important, so it's like the golden ratio important because they have a correlation or they are related to each other by any means. That's all, sir. Thank you.
Hi everyone, my name is Rina Ima Bras from Section Delta, first year college, and I answered the three related questions about the video I watched about the golden ratio and Fibonacci in music. Number 1. What math concept the fully discussed on assigned video? The discussion in a video I watched it's all about the golden ratio and Fibonacci in music. Number 2. What is about the concept? Cite few more real-world case or example that would show the concept. The Fibonacci sequence or golden ratio are fascinating idea to look at on their own. They are analyzed a lot in physical art such as painting and nature. However, not much is research in their connection to music. For example, flowers petals. The number of petals in flower constantly follows the Fibonacci sequence. Another example, face. Face, both human and non-human, abound with example of the golden ratio. The mouth and nose are each positioned the golden section of the distance between the eye and the bottom of the chin. Last number. What are your insight about these mathematical truths or sentences? They say that math is very hard, but when you understand it, you will realize that math is very fun. It helps me not and fail in a math test and exam. We also use math on daily basis. Mathematics is the science or study of numbers and their operations, relations, combinations, generalizations, and abstraction. That's all. Thank you.
Hi everyone, I am Christian Eric Henson from Section Delta. Today, I will answer the questions about our topic, the golden ratio and Fibonacci in music. The first question is, what math concept is fully discussed on your assigned video? So the math concept that is fully discussed on my assigned video is all about the golden ratio and Fibonacci that engage in music. Question number 2. What is about this concept? Cite few more real-world cases or examples that would show the concept. The golden ratio and Fibonacci sequence plays a big part in Western harmony and musical scales. For example, the golden ratio can be found throughout the violin by dividing the lengths of specific parts of violin. As well, as being used to craft violins. The golden ratio that comes from the Fibonacci sequence is also used for saxophone mouthpieces in speaker wires, and even in the acoustic design of some cathedrals. Last question is, what are your insights about these mathematical truths or certainties? My insights about these mathematical truths or certainties is it can help everybody have a knowledge in involving different art, especially in music. This serve as a knowledge of each artist when they are composing different music. Once again, I am Christian Erikenson from Section Delta. Thank you for listening.
I'm Alan Lakenta from Section Delta. So today, I will discuss the three questions about the golden ratio and Fibonacci in music. Number 1 question. What math concept is fully discussed on your assigned video? The concept is fully discussed on video I watched. It's all about the golden ratio and Fibonacci sequence in music. Number 2 question. What is about this concept? Cite few more real-world causes or examples that would show the concept. The concept is all about the importance of golden ratio and Fibonacci sequence in music. Some say the golden ratio and Fibonacci sequence is evident of music. For example, the opening xylophone solo and the third movement has rhythmic pattern following a Fibonacci sequence, going 1, 2, 3, 5, 8, and going back down. What are your insights about this mathematical truth or certainty? Insights about these mathematical truths or certainties. There are many things in this world is related to mathematics, just like nature, music, and daily routine. That's all.
My name is Andrea Gonzaga. I'm from Section Delta. This is my understanding about the video that given to us. And these are the questions. Question 1. What math concept is fully discussed on your assigned video? The concept that fully discussed is golden ratio and Fibonacci sequence in music. The second question is, what about this concept? Cite few more real-world cases or examples that words show the concept. The concept is all about the golden ratio and Fibonacci sequence in music. I have here an example that relates the golden ratio and the Fibonacci sequence in music. Like the golden ratio can be found throughout the violin by dividing the length of a specific part of the violin. Follow the Fibonacci sequence in a piano that relate in a relationship present a number of the notes. The third question is, what are your insights about this mathematical truth or certainties? For me, my insight about this mathematical truth, this mathematical concept are universal. This is not just about numbers or measurements. Mathematical concept can be seen in both nature and human nature such as art.
Hi, my name is Christian Groda from Section Delta. Today I will answer the three questions that related to the video that I've watched. So question number 1, what math concept is fully discussed on your assigned video? So the concept that discussed in the video is about the golden ratio and Fibonacci sequence in music. Question number 2, what is about this concept? Cite few more real-world cases or example that would show the concept. The golden ratio is used to the interval between carrier and modulator, such as the resulting timbre is an enharmonic cloud of golden ratio related partials. To get a sense of what the golden ratio may sound like as a music interval, starts from here and let the sounds slowly work their way into your brain.
and some says the golden and the Fibonacci sequence be evident in music for strings, percussion, and celesta. That statement is from Hungarian composer Béla Bartók. Example, the opening of xylophone solo in the third movement has a rhythmic pattern following the Fibonacci sequence, going from 1, 2, 3, 5, 8, and then back down 5, 3, 2, 1. And another example that we can say in real world is, for example, flower or galaxy and etc. Question number 3. What are your insights about these mathematical truths or certainties? So, composers and instrument makers have been using the Fibonacci sequence and golden ratio for 100 of years to compose and create music. This is the reason why music is continuously nowadays. That's all. Thank you.
I am Romulo B. Divino from Section Delta. Question number 1. What math concept is fully discussed on your assigned video? Answer. The concept of this video is all about the the golden numbers of Fibonacci's number. When we see Fibonacci, it is an Italian mathematician. Question number 2. What is about this concept? City few more great world keys or example that would show the concept. Answer. This concept is all about mathematical, and for example, the number of petals in a flower consistently follows the Fibonacci sequence, include the lily which has 3 petals, buttercups which have 5. And the last question, what are your insight about these mathematical truths or sentences? Say mathematics is so difficult, but when you understand it, you will realize that mathematics is so joyful that when you appreciate a thing, then you will see the beauty and importance of an object. When we see mathematics, it is a difficult, but when you understand, this is joyful. Thank you.
Good day everyone, my name is Ace Iscala from Delta Section, and for this video I'm going to answer the three related questions about the golden ratio and Fibonacci sequence. First question is, what math concept is fully discussed on your assigned video? The concept is fully discussed on assigned video is all about the golden ratio and the Fibonacci sequence in music. The second question is, what is about the concept? The concept, the cite more real world cases or examples that would show the concept. The concept is all about the important impacts and use the golden ratio in Fibonacci sequence. For examples of the golden ratio is shields. The shields is shape a rectangle in which the ratio of the sides AB is equal to the golden mean is pi and can be repeated into infinity, and which takes on form and of spiral. It's could be the logarithmic spiral, and its bounds in nature. The last question is, what are your insights about the mathematical truths or certainties? My insights about this mathematics is about the series of number. There are many things in this world, in our natures, is related in math, but it's very hard to understand and solve the patterns. But but when you understand it, you will realize the math is so very enjoy and joyful. Thank you.
I'm Aljon Fernando from Section Delta, and for this video I am going to answer the 3 related questions about the video I watched. So, question number 1 is, what math concept is fully discussed on your assigned video? The math concept that is discussed in the video is about the golden ratio and Fibonacci sequence in music, where Fibonacci sequence makes a golden ratio or P. As it gets higher and the ratio between the numbers gets closer to 1.618 or P. Second, the Conacol rhythm by B.C. Manhunat, which involves clapping and vocalizing with the Fibonacci sequence 1, 1, 2, 3, 5, 13, 21. Also, when you multiply the length of a song by 0.618, which is the inverse of P, you find that golden ratio such as the I Am In My Feelings by Drake, 202.8 seconds times 0.618 is equal to 125.3394 seconds, where we can find the golden ratio. Question number 3. What are your insights about these mathematical truths or certainties? So, the golden ratio and Fibonacci sequence is universal or versatile, as we can only find in mathematics but also in music, nature, art, or in any fields. It is astonishing that we can create music using this concept, or rather the musicians, the composers, use this to create a masterpiece and bring us a beautiful song or a beautiful piece of classical music. And that's all, and thank you for watching.
This is my video presentation about the golden ratio. Golden ratio. The fully concept about those video, sir, is about the golden ratio. The golden ratio is we saw in the world and the music that they comply the number, and the answer is he used to play that the piano. So I fully learned about the video. Is so amazing, and we can see a golden ratio everywhere in our world. About what I saw about this video, because there is certainty that will happen, because I saw the correct explain about our golden ratio, and it's just the fact that we can see whatever we look or where to go, and didn't know it was golden ratio because we benefit from the harvest in our day-to-day lives.
I am Alvin Elosol from Section Delta. Today, I'm going to answer the guide questions related to our topic or to the video that I have been watched. First, what math concept is fully discussed on your assigned video? This mathematics video fully discusses what is golden ratio and Fibonacci sequence in music. And the second one is, what is about this concept? Cite few more real-world cases or examples that would show the concept. Since the time of ancient Greeks, artists, designers, engineers has been fascinated by the golden ratio, or also denoted as phi. The golden ratio was first described in Euclid's Elements around 2300 years ago. Golden ratio is the ratio of the two quantities is the same as the ratio of their sum to the largest value of the two quantities. The golden ratio, also called as the golden section or the divine proportion, and is one of the famous irrational numbers. This mathematical concept is said to appear in nature and in various iconic pieces of art. It has allegedly inspired artists like Michelangelo and Leonardo da Vinci. The Mayans, Egyptians are also said to have incorporated this divine number into works of art and architecture such as the core Romanesco broccoli and the shell of the Nautilus are often given as typical example of golden ratio. It is founded by dividing a line into two parts so that the long part divided by the short part is equal to whole length but divided by the long part insert. What are your insights about these mathematical thoughts or certainties? As I know it, I having a realization that golden ratio describes the relationship of two figures, whereby the two numbers seem to be in some form of complementary ratio. In this, we have to link Fibonacci sequence and golden ratio. What we have to do is, we must look at the ratio between two consecutive numbers in Fibonacci and observe the pattern this ratio takes as you use ever higher numbers. Furthermore, golden ratio has fascinated the world's most knowledgeable people for millennia since its discovery. And we have seen its influence in some of the finest works mankind has ever produced. And many things around us is nature, such as the petals on flowers, Nautilus shells, fruits, and in even facial features and in compliance of golden ratio. That's all, everyone. Thank you for watching and listening.